Hi, and welcome to another edition of Math with Mr. Douglas. Today we're looking at factoring and simplifying and other crazy math stuff. Maybe even a little bit of Halloween trivia. Are you ready? Here we go. Hi, and welcome to Math once again. Today, of course, is actually just around Halloween time. So Halloween is one of my favorite days of the year. I love Halloween stuff. This year, the family is dressing up as the Incredibles. So I've seen an Incredible family wandering around the streets. I say, hey, is that the Math Jedi? Maybe it is. But today in math, we are going to be talking about simplifying, factoring, and other fun stuff. And of course, this all relates to algebra. And it's getting used to making sure we know how to work with some rules in algebra. So the very first thing we're going to look at today is the distributive property. This kind of sets up the table for everything. So we're going to look at the distributive property. Now, this is one of the coolest properties there are in math, and it's lots of fun. It involves arrows, and I love arrows. So the distributive property is basically, if I'm teaching, if you had me in an actual class, you would hear me talk about opening up the brackets. So open the brackets. And this is usually a pretty good idea to do. So I'm going to go over kind of the rules, some common kid stuff I always hear, and give you some little tips of advice. So let's just get into it. So basically, here we go. Let's start off nice and easy. 5 bracket x plus 2. Okay, so 5 bracket x plus 2. If I ask you to go and distribute that, or to open up the brackets, basically a couple of things you got to kind of realize. Number one is when a number is beside a bracket, like it is right here, there is a hidden multiplying sign. Now, why do we hide things in math? I don't know, we just do. So imagine there's a little multiplying sign here. I like using the circle so it doesn't get confused with x's, which are variables. And basically all you need to go and do now is multiply each thing in the brackets by the thing outside the brackets. So what you end up getting here is 5, I'm going to go really slow, 5 times x plus, because that's a plus sign, right? See the plus sign has been down? 5 times 2. And that gives you 5x plus 10. Boom. Now you can't combine 5x plus 10 because those two terms are not similar or like. So that's distributing. Now if you have a sneaky teacher, do you know some teachers sometimes do? Here's another example. This is a sneaky teacher. Here we go. Let's just have it say it was D take away 7 bracket 2. What? The 2 is on the other side of the bracket. I've seen this happen a few times. I'm not saying I ever did it, but it's the exact same thing. You're just doing it this way. So some teachers will just do this, they're probably just bored. And they're like, let's see if they understand what to do. So this is 2 times D, so 2D, to 2 times negative 7, which is negative 14. Got it? Let's get one more color in to show one more different thing, just to make sure you're understanding how this kind of works. Maybe some purple. Sure, one more purple. I'm trying to fit in all my examples here. I didn't do a very good job of spacing. So here's a purple example. It's going to be like this. Negative 2 bracket negative y take away 1. This is a good one. So this is negative 2. So that sign to the left is going to go with it. So it says negative 2 times a negative y and negative 2 times a negative 1. So negative times negative goes to positive, so this is positive 2i, and this is going to be positive 2 like that. Again, you can't combine these like terms because they are not similar. They do not have the same variable or the same exponents, etc., etc. So you can't do that. Now, let's see. Let's get rid of that one. Oops. How do I get rid of this? Where are we? There we go. And let's just do this a little bit more now. So now you have the general idea of distributing. So now we're going to go and distribute. And simplify. So if you haven't seen my other video on algebraic expressions and simplifying those ones, you want to check that out. So here's an example. Let's just start off nice and classic. 2 bracket x plus 3 plus 5 bracket x, I don't know, minus 1. So we're going to go and distribute all those. So that means opening up all the brackets and then we're going to combine our like terms. So that's kind of the order. You open the brackets, and then you combine your like terms. So that is going to give us 2x plus 6 over here plus 5x minus 5. Now, if you have seen my other videos, I like to circle things, so I like to circle stuff. I'm going to circle this common things. You always circle with the sign to the left. So notice I'm going to circle this plus sign right here. And I'm going to go and circle the other stuff. Now, if you're pretty good at looking at stuff, you don't need to do the circles. But I like to circle, so it makes it kind of obvious of what's happening. Right, cut down on those little mistakes. So let's go and combine our 2x and our 5x, and that would give us 7x's. And we have 6, take away 5, which just give us positive 1. Boom. There you go. That is distributing and simplifying. Let's do another example to get us going. Let's do this one. Let's do 3/4 of 12x minus 8. So let's see, what numbers are we going with? 12x minus 8, which is pretty good. I'm working with 3/4. And let's go with the classic take away. Whoops. Well, can I squeeze it in? Take away x, take away 6. Oh, look at that. Did I squeeze it in? I did. Woohoo! All right, let's go and distribute these ones. Again, you should have calculators right now, and you should be used to using calculators. So 3/4 times 12x is going to give you, I think, 9x. And 3/4 take away 8 is going to take you to negative 6. This negative here, I put it here for a reason. So this is a negative 1 distributing. So the negative 1 times this is by the x, so it's negative x. So don't forget about that. And this is negative times another negative, which is going to give you a positive 6. This is always exciting. Let's go and combine our like terms. So I'm going to combine another way. I like to use like arrows like this sometimes. And I use different levels of arrows, so that kind of helps me. There's different ways to kind of make things obvious. I use this because I'm pretty good understanding that I'm taking this entire sign. I had done this for a while, so I'm pretty good not having to do the circle stuff. But the circle stuff definitely makes you not forget about the sign on the left. Up to you. So let's start with our x's. 9x minus x, so that's going to be giving us 8x. And negative 6 plus 6 gives us 0. Huh, that's pretty cool. Your answer is just 8x. That was awesome. And there you go. So that's the distributing and simplifying. Let's go backwards now. Yeah, we're going to go backwards. It's going to be super exciting. We're going to go backwards. So let's get rid of this. Let's go over here. And we're going to go backwards. Now, what's the backwards of distributing? So if you had to go opposites, right? So we're going opposites. So if we're going opposites, so what are the other kind of famous opposites that you're thinking of? Obviously, you're thinking of Batman. What's the opposite of Batman? What's it going to be? Did you just say Joker? Yes. I hope you did. If not, now you have the idea. What's the opposite of, I don't know, what's another good one? Let's see, Batman, Joker, Superman. What's the opposite of Superman? Some might say Bizarro. Or you might go Lex Luthor. Right, the complete opposite. Lex Luthor. Oh, what other stuff do we have? Well, you get the idea. If I was going to distributor property, what's the opposite of a distributor property? What's the opposite? It would be the factoring. So it's the opposite. Cool. So let's do that. We're going to spend some time on this. This is the part that probably most students struggle with a little bit. Let's go back to our original idea. If we had to go and distribute this. Oops. So I have to go and distribute this. I would get 3x plus 18. If they ask me to go and factor this now, which is the opposite, I need to go back to this state. So if I had to go and factor 3x plus 18, I need to ask myself two things. Now this one's a little bit easier. I need to look at both of my terms. That's one term. This is another term. And say, what is my GCF? GCF, grade 6. Probably grade 6, maybe grade 5. I have videos on greatest common factor if you want to go take a look. But what's the greatest common factor of just the coefficients? So just the 3 and just the 18. What's the greatest coefficient? Or greatest common factor of the 3 and the 18? The GCF. Well, that's going to be a 3. Great. You write that down, and you leave big open brackets. And what you ask yourself in your head is you say in your head, 3 times what gives me 3x? What is it? 3 times, x. 3 times what gives me positive 18? Positive 6. And you're done. This is now factored. So look at these two things, because that is distributing. This was factoring. The opposite, going backwards. Let's do a few more examples, because typically students need to see a few more examples of this one. So we need a few more examples of this one, of factoring. I'm going to stick this nice blue color. I like blue. And I'm going to show you the distributing first. Should I show you the distributing first? Yeah, I'll keep showing you the distributing first. There's one little thing I want to remind you, though. This is important. When you have x times x, you end up getting x squared. When you have x to the third times x to the second, you end up getting x to the fifth. So what's the rule? The rule is add your exponents, not multiply them. So when you're multiplying, this seems weird, when you're multiplying, you have to add your exponents. So quick, let's see if you figured it out. What's x to the 7th times x to the 3rd? What's that going to be? It's going to be x to the, did you say it out loud? X to the 10th. Well done. Let's do one more, because we need to do this. This is going to be important. Let's say you had 2x to the 4th times 5x to the 7th. What would you get there? You multiply your coefficients together, and you get 10. And you multiply your x's together, and you get x to the, add your exponents, and you get 11. Okay, whew, that was a little bit of a sidetrack. So let's go and now actually factor something. And we're going to actually factor. So the instruction is to factor. And we're going to factor, and you'll see why this is important in a second. 6, let's just get right into it. 6x to the 3rd plus 20x to the 5th. Cool. Now, what's the GCF of these two terms? First, look at your coefficients. So ask yourself, for 6 and 20, what is your GCF? What is it going to be? Let's see. Is it 1, 2, 3, or 6? I think it's going to be just 2. So we know you're going to have a 2. But now you must also ask, what is your GCF going to be of x to the 3rd and x to the 5th? How many x's are common? Well, what does x to the 3rd really look like? It looks like that, x, x, x. What does x to the 5th look like? X, 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 x. How many of those are common? Well, there's 3 here, and there are 3 common ones there. So the GCF of x to the 3rd and x to the 5th is x to the 3rd. There's 3 common x's. Does that make sense? Nod your head. Good. Now, remember I asked you, you have to ask yourself, 2 times what gave you 6? 3. I factored out 3 of these x's. I factored out 3 of them. How many are left? 0. Nothing. They're all gone. Moving on. 2 times what gives me 20? 10. I took out 3 of these x's. How many are left? Just 2. Boom, that's factored. Now that's probably going to be more challenging questions. And the great thing is that for these questions, you can always go and check your answers. That's so cool. Because when you go backwards, you can check by distributing. So just go back and ask yourself, is 2x to the third times 3 6x to the third? Yes, it is. Woo. Is 2x to the third times 10x squared going to be 20x to the fifth? Yes, it is. Good stuff. You want to see another one? Of course you do. I said there was supposed to be some Halloween trivia, right? Didn't I? Hey, have you seen the Halloween trivia? You know the movie called Halloween? Who's the bad guy? Who's the bad guy? His name is Mike Myers. Sounds like a superhero. Mike Myers. Mike Myers. And he's the guy with the really creepy white mask. A white hockey mask, actually. Well, that mask is actually... It's actually Captain Kirk from Star Trek. So that movie had such a low budget that they had to go and they bought the cheapest mask they could find, which was a Captain Kirk Star Trek mask, and they painted it. They spray painted it white, and that was Mike Myers' mask in the Halloween movie. Good stuff, huh? Told you there'd be some Halloween trivia in there. Nothing to do with math. That's why you come to the Math Jedi. Here we go. Let's do another one. Let's do a medium one and a harder one. So let's just go and simplify. 10x, take away 8. Let's go and factor this. So go and factor this. We're going to factor it. So this one, there's only 10s and 8s. So the GCF is going to be, I think, 2. And that's going to leave me with a 5x minus 4. Now, make this a little bit harder. Let's say you had 12. Let's make it really hard. Sure. X to the third, y to the second. Take away 10. X to the second, y to the third. See what I did there? Crazy. Okay. Work on your 12 and 10. What's your GCF of 12 and 10? That's going to be 2. Notice I took the positive, not the negative. So I took 2. And ask your x's. How many x's are common? There's 3 here. There's 2 here. How many are common? 2 are common. There are 2 y's and there are 3 y's. How many are common? 2. And what is left over? 2 times what is 12? 6. I took 2 of the x's. How many are left? 1. I took 2 of the y's. How many are left? None. So I leave it. I don't write y at all. They're all taken. 2 times what is negative 10? Don't get tricked by that. It's negative 10, right? It's negative, oops. Yeah, negative 10. I wanted to make it yellow to make a point. It's negative 10, so don't get tricked by that. It's negative 5. And I took 2 of the x's. How many are left? None. I took 2 of the y's. How many are left? 1. And there's your answer. Boom. So that is factoring, simplifying, and distributing all in one. Hope you enjoyed. Happy Halloween. Go like and subscribe right now. Share with all your friends. Give me a shout out. I think that's what all the kids are calling it nowadays. And until next time, have a great day.